Let us talk about some more functions and their graphs. So I'll basically talk about modulus function, signum function, and greatest integer function in this lecture. Okay, so let us start with the modulus function. Modulus function. I hope you know by now what is modulus. So mod of something is denoted by this. So for example, this mod of x. It is also known as absolute value function, right? The modulus function is also known as absolute value function. So what happens in this is, let us say you put x equal to 1, so you will get mod of 1, which is 1. If you put x equal to minus 1, let us say, then you will have mod of minus 1 and the absolute value will be 1. If you put 0, you will get 0 as your output, right? So what is mod doing is, right, it is giving you, for example, let us say you have got this real number line. Now if I ask you, at what distance is this from this 0, right? You will say this distance here is 1 unit, right? If I ask you at what distance is this point is from 0, you will say this point is at 1 unit distance, right? So the answer for minus 1 and 1, right, distance from 0 is same for both of these points. So if I put 1 inside the modulus or minus 1, it is giving me 1 here. And if I want to define it formally, it will give me values like this. It will give me x equal to x or minus x or 0. It will give me x when x is greater than 0. It will give me 0 when x is equal to 0, or it will give me minus x when x is less than 0. Now, can you tell me what kind of value is this? Is this a positive value or a negative value? This is a positive value. This minus x written on this screen is a positive value. Why? Because I have defined it for x less than 0. When x is less than 0, let us say minus 3, the negative of this will be something positive, which is this minus x, right? If you look at this x here, this is also positive because x is greater than 0 and this is 0, right? You can also write it in this format: f of x is equal to x or minus x when it is greater than or equal to 0, and minus x when it is less than 0, right? Now the part that had 0 here is covered here itself. Okay, so this is the shorter form, so it is better to write like this. Or if you don't want to write it here, you can write it here also, because in that case also minus 0 will also be 0. Now if you want to make its graph, you see, when I put 2, what is the distance from 0? It is 2. When I put minus 2, it is again this distance is 2, right? So if you draw this Cartesian coordinate system, when I put 1, I'll get 1. When I put 2, I'll get 2. So this is the corresponding point. But now look at the negative side. When I put minus 1, I'll again get plus 1. When I put minus 2, I'll get plus 2, right? So if you join these, when I put 0, I get 0. So this is also a point. When I join these points, it will be like this. This will be the graph of mod x. Okay, as you can see, you can put any real value of x here, any real value. So it is defined for every x, right? So domain of this function is set of all real values. But if you look at the range, it gives me something non-negative always, non-negative. So if you put 0, it will give you 0. but if you put anything positive, it will give you positive. If you put anything negative, it will give you positive. So it always gives you non-negative real numbers as its range. So what is the range here? Range is set of non-negative real numbers, right? So its range is non-negative real values. I have spoken about modulus function in details in one of my lectures, which I'll put in this playlist itself, right? So if you want to know about this function in more detailed manner, then you can visit that playlist. Okay, I'll put in this same playlist of relations and functions some extra lectures in the end, where you will find the discussion about modulus function in details. But for this chapter, it is enough to understand. Next function that I am going to discuss is SIGNUM function. What is special about this function is, let us say I put anything positive inside it. It will give me 1 as my output. Okay, so let me write it here. If I am putting anything, so I always write x and f of x, right? So when I am putting x, which is greater than 0, right, which is positive, so the output that I am getting is 1 in SIGNUM function. Okay, so there is this SIGNUM function inside which is happening. So what is happening in SIGNUM function is that when I am putting something positive or greater than 0, it will give me output equal to 1. When I am putting 0 here, it will give me output 0. When I am putting something negative or less than 0, it will give me output -1, right? So if I want to define it formally, I can write that it will give me 1 when x is greater than 0. It will give me 0 when x is equal to 0. It will give me -1 when x is less than 0, right? If I put anything negative, the output this SIGNUM function or this operator will give me is, when I put something negative, it will give me -1. When I am putting something positive, it will give me 1, right? So the outputs that I am getting are 1, 0 or -1. And inputs, I can put anything positive, I can put anything negative, I can put 0 also, right? All these values I can put, but when I put positive values, I'll get 1. When I put negative values, I'll get -1. When I put 0, I'll get 0. So this is the output set. Or if you want to talk about domain or range, so what is the domain? I can put any real value of x, right? Positive, negative or 0. But what is the range? For any value that I put here in as my domain or as the value of x, the range that I am going to get is only these three values, -1, 0 and 1. So this is the range of SIGNUM function. Okay, and another way to write SIGNUM function can be mod x by x when x is not equal to 0. So I have written this function for positive as well as negative values of x. This will give me my result for positive values of x and for negative values of x, and it will be equal to 0 when x is equal to 0. Now you can notice, if you put anything positive, let us say f of x equal to mod x by x, this is what I am solving. So if I put anything positive, let us say I am putting 2, okay, so what will be f of 2? It will be equal to mod 2 divided by 2, which is 2 by 2 equal to 1. If I am putting -2, so what will be my f of -2? It will be mod of -2 divided by 2, which is again 2 by 2 and hence 1, right? So what I am getting here is, no, for -2 I'll have to put -2 here. So for -2, 2 divided by -2, it will give me -1. So when I am putting negative value, let me put another value. You may not get confused. So f of minus 3 is mod of minus 3 divided by minus 3. Right? I need to replace every x with minus 3. So it will give me 3 in the numerator and minus 3 in the denominator, hence minus 1 as my value. So when I am putting negative, I am getting minus 1. When I am putting something positive, I am getting 1. Obviously, for 0, it is defined as being equal to 0. So this is the function. If I want to draw its graph, I know the only output values that I am getting are 0, 1 and minus 1, and at every positive value of x, I am getting, now this 1 I am not getting at 0, right? At every positive values of x I am getting 1. So I'll get 1 from, for this value of x, for this value of x I'll get 1, right? For all these values I'll get 1, but for 0 I'll get 0. So I'll put a open circle here or an unfilled circle here. Similarly, here also I'll put an open circle, but for all these negative values of x, I'll get minus 1 as my value for this function. So this will be something like this. So this is the graph of SIGNUM function. Domain and range we have already seen. The domain of this function is all real values, because at 0 also we are getting this value, which is 0 itself, right? For positive values we are getting this value, which is 1. For negative values of x we are getting this value, which is minus 1. So domain, yes, is all real numbers. And what is the range? Range we have already written is minus 1, 0, 1. This was a little bit about SIGNUM function. The next function that we are going to discuss here is the greatest integer function. Greatest integer function, which in short form can be written as GIF. This is also known as box function, right? And this is denoted by f of x equal to box x. What it does is, let us say I put something like this, 7.2. The output that it gives me an integer, the greatest integer, which is less than 7.2. Now what is the greatest integer that is less than 7.2? It is 7. Or if you want to understand it on the number line, let us say this point is 7.2. Now you need to look at the left side of 7.2, okay, and need to find the greatest integer. So obviously on the left of this 7.2 you will have the greatest integer as 7, right? So this is what the output will be. If I put, let us say 6.3, the output it will give me is 6, because on the left of 6.3 I'll have the greatest integer as 6, okay, right? I hope you have understood. Now you need to tell me, if I put minus 3.7, what will be the output? It will be equal to minus 4. Why? Because this is minus 1, let us say minus 2, minus 3, minus 4, and somewhere here I have got minus 3.7. So when I am putting minus 3.7 in this function, in this box function, I just need to look at the left of minus 3.7 and need to find the greatest integer, which is minus 4 in this case. So minus 3.7 will give me minus 4. Obviously, so let me write some of the values for you. Minus 2.3, minus 5.7, 6.3, 3.9, So this will give me minus 3, this will give me minus 6, this will give me 6, this will give me 3. This is how this function works. Now if you look at the input values, even if I let us say put 1, it will give me 1 back, right? Because it has to give me an integer which is less than or equal to the input value. So 1 will return me 1, okay? It itself is an integer, so it will give me 1. So if you look at the output, we are getting all the integral values, right? And if you look at the input, I can put any real value of x here. So if you want to draw its graph, you know the output values that you will get will all be integral values, right? Output will be an integer for this greatest integer function. What is the function that we are talking about? This greatest integer function or box function, box x, okay? Now you tell me one thing before drawing this graph. Let us say I put 1 here. What is the value that I get? 1. When I put 1.1, I'll get a value 1. When I put 1.3, I'll get 1. Up to which value I'll get 1? If I put 1.9, I'll get 1. If I put 2 here, then I'll get 2, right? Or when I increase these values, I'll get 2. And up to 3, I'll keep getting 2. So between this, let us say this is 1, this is 2. Between 1 and 2, at 1 I am getting 1, so this is one of the points that I am getting on the graph. And between 1 to 2, here, everywhere I'll get 1. 1, 1, 1, 1, 1, except this point which is 2. When I put 2, I will not get 1. What do I get here? I'll get 2. When I put 2, I'll get 2. But when I put 2.1 or 2.2, 2.3 up to like 3 when I go, so between 2 and 3, everywhere I'll get a value 2, right? So I'll keep getting values 2 until unless I reach at 3. At 3, I will get this value here, which is 3, right? So this is how we will make this graph, okay? So I'll put open circles here, right? And join this, okay? And similarly, you can draw another step here, and you may go on like this, all right? Because between 3 and 4, for every point between 3 and 4, you will get a value 3, right? This is 3 and 4. You will get every value which is 3, right? For every point. For example, this point, you are getting value 3. Similarly, between 4 and 5, you will get a value of 4 at every point between 4 and 5, right? At 4, you obviously will get 4. At 5, you will get 5. So you will not get 4 here. I hope you have understood what I am trying to say here. Let us look at the negative values. Now you tell me, between minus 1 and minus 2, if I take a point here, what is the greatest integer that is on its left? It is minus 2, right? So any value between minus 1 and minus 2 that you put, right? Any x between minus 1 and minus 2, what will be the value that you will get? Minus 2, right? For all these points, you will get minus 2. But at minus 1, you will get minus 1. Between 0 and minus 1, let us say you take this point. For all these points between 0 and minus 1, you will get minus 1 as your value, right? So let me put an open circle here and join this. Why did I put open circle here? Because at 0, I will get 0 itself. I will not get minus 1. But for all these values, the greatest integer on the left of these values is minus 1, okay? Similarly, between minus 1 and minus 2, the greatest integer will be minus 2, right? Greatest integer less than these values will be minus 2. Okay, so for here I'll put an open circle and then this line. Alright, I hope this is the graph that you have understood for greatest integer function. Now let us talk about domain and range. So what is the domain? You can put any real value of x, right, and it will return only the integral values. So the range is set of integers. So I now think that you have understood these basic functions. Okay, let me check. If I write, let us say this is box minus 7.6, what will be the result? Right, tell me what will be the result? Minus 8. Why? Because you will, let us say this is minus 8, this is minus 7, minus 7.6 will be somewhere here. So you will look at the left of minus 7.6, right? You will be looking at the greatest integer that is just lesser than minus 7.6. Obviously it is minus 8. Okay. And let me ask you, mod of minus 3.5, what will it be? It will be equal to 3.5. Mod of 0, it will be equal to 0. If I ask you signum pi minus 4, what will it be? It will be equal to minus 1. What will be signum? What will be signum x squared plus 1? It will be equal to 1. Why? Because inside this bracket, for the value of x, I have put pi minus 4, which is something negative, and if it is something negative, it will return me minus 1. Here it is always positive, right? The value that I have written here, x square plus 1, is always positive, so it will return me 1. Okay, and of course if I put 0 here, it will give me 0 as the result. So these were some basic functions. Okay.